So teacher says, last year I did an experiment to get value of g, the acceleration due to gravity. The idea was to time the ball bearing rolling down an inclined plane. You can then calculate acceleration for an incline at this angle and hence get the value for g. A schematic of the ramp is shown. This is the length, this is the height, and these are the measured values. So from here to here is 2 meters, from here to here is 6.10 centimeters. For the ramp we used V-shaped aluminum channel. Here is a schematic of a cross-section of the ball in the channel, so that is the ball that rolls towards us, let's say. D is diameter, that is distance from here to here. Distance from here to here is the half of diameter. Same is distance from here to here. Okay, and then there is this thing. When it touches there, the ball touches the sides of that ramp. Okay, and this is the timings. These are the timings that he calculated for the distance: half meter, meter, meter and a half, and 2. So he started ball somewhere around here, that was a half meters, and then started ball here, here and here, and take different measurements. So from the half meter it was somewhere around 2.74 to 2.5 seconds for 1 meter, 1.5 and second meter. That these are the distances and times. To answer the question, enter the value g that you think is the best supported by the data. You may change your mind at any time and enter a new value. The last value entered before the quiz. Okay, that is something for the quiz. Let us see how we can calculate the g. How I did that 5 years ago. Okay. You place distances here, and you place times here. And these are the average time for this distance. This distance, average time. This distance, average time. This distance, average time, and so on. And that is the acceleration with usage of these here numbers. For the distance 0.5 meters, time is 0.1626. Now that is not time, that is acceleration. That is the acceleration for that. This is acceleration for 1 meter, for 1.5 and for 2 meters. They are all similar as they should be. And average for this acceleration is 0.1636 meters per second square. And this is the equation for the acceleration from the known equation. That was how we say that: v is equal v0t plus at squared divided by 2. So there is no initial velocity, and from here what did I do? This is not v, this is x. This is the distance. X is v0 v02 plus a2 squared divided by t. Initial velocity is 0, so from this equation here, as you can see, you get a to be 2 times x divided by t squared. And there is nothing very special about this equation, that is normal. And this is the acceleration in its motion down to this inclined plane. So this is the acceleration for the ball from here to here. We have calculated this using, how do you call this? This is Excel. So when we find acceleration, now we go to find other things. Yep. So potential energy at the top of the ramp is equal to the kinetic energy at the bottom. And at the top of the ramp, that is mgh, and the bottom of the ramp, that is mv squared divided by 2 plus e plus omega squared divided by 2. This I is angular momentum, this is the angular speed. this is kinetic energy of the rotation, this is kinetic energy of the straight motion. So I'm just going to show you something more. It was not very difficult, but not very easy either. So from here there is at the top of the ramp, that is mgh, this is kinetic energy, this is the kinetic energy of the rotation, this is kinetic energy of the straight motion, let's say, and from the rotation you have this, from this equation and so on, and I will not show you anything more. So from here you can do it yourself, or for complete written answer please follow the link in the description. If you want more of this, please subscribe and tell your friends. And I will just tell you that G that is calculated from this is 10.1066 meters per second. That's all there is to it. Thank you. Bye.